Mm, Hello everyone, myself Dr. Abhishek Shukla. Today I am presenting this topic, fundamental of fiber optics. I'm working as an assistant professor in Department of Applied Science and Humanities in IIMT College of Engineering, Greater Noida. Now, the whole contents, my presentation is divided to subcategories, that is, what are actually optical fibers, what is look-alike, what is the structure-wise optical fiber, and regarding fabrication, how this optical fiber prepared with the help of different techniques, and also the working principle of optical fiber. On the principle it works, and on the other slide, I will discuss some its classification of optical fibers, and also will discuss advantages and disadvantages of optical fiber. And at the end, last two slides, I will discuss its application, where it can be applicable, these optical fiber. And at the end, I will conclude some points. So at the bottom, you can see the picture that is related to the optical fiber. It's black colored jacket, this silver color, this plastic or glass, and these different colors are tubes like structure from which a fiber like structure is coming out. This is said to be optical fibers. Means optical fiber is nothing, just it's just an optical fiber in which hair thin like structures made up of either glass or a plastic material. So actually, why we need this optical fiber? Why this advancement in the optical fiber, or why we need this optical fiber? As we know that communication, without communication, we cannot communicate from one end to another. So for the proper upliftment of the communication, we have to need some good medium to transfer our data from one end to another end in a specific way or in a lossless way, so that we can communicate from one person to another person, or one community to another community, or from one country to another country. So we have to need this any good medium to transfer these our data from one end to another without any loss. So for this specification, optical fiber till now is a good source, good medium to transfer our data in a better way. So according to lookalike, this optical fiber is nothing, it's just a small, thin hair-like structure, cylindrical, made up of glass and a plastic material. The fiber which are used for optical, basically optical communication is used in which we have to guide wave in the core medium. Its function is to guide either visible or IR light over a long distance. Means according to our need, we can guide, we can transfer our data from one end to another in a different way. Now, a look-alike means how structure is look-alike. So you can see from the picture, in the structure of optical fiber, you can see that in the middle, its core is defined, its core, and outer end its cladding, core in which our light signal is transmitted. And cladding is to also it's some changes in the refractive index is quoted above the core. And above cladding, we have quoted the coating or shielding, and also to protect some atmospheric effects like pressing or pressure or temperature, high temperature. So we can use further jackets that is yellow or this shown in orange color. So it does only for the some insulation or for protection from the environmental issues. So core, as you can see, core is just a central tube of very thin size made up of optically transparent dielectric medium and carries the light from transmitter to receiver. The core diameter can vary from about 5 micrometer to 100 micrometer. Means its thickness, it should be around 5 micrometer to 100 micrometer. And the cladding is said to be outer optical material surrounding the core having refractive index lower than the core. Means for the good communication channel, we have to keep this mind is that the refractive index of clad must be lower than the core. Otherwise, if this specification is not fulfilled, then proper transmission of our data will not occur. So we have to keep these things in a better way. So it keeps to the light within the core throughout the phenomena of total internal reflection. Now, buffering is to protect these two components, cladding and the core. It's just for the protection of these two basic components, clad and the core. So buffer plastics that protect the fiber made up of silicon rubber. Basically, it's made up of silicon rubber. The typical diameter of fiber after coating is about 250 to 300 micrometer. Means this side should be around 300 micrometer, and the core cladding diameter should be greater than 100 micrometer to 150 micrometer. So basically, we have to keep in mind that size thickness should be not be core should be around 5 to 100 micrometer, and the cladding should be around 100 to 150 micrometer, and buffer should be around 250 to 300 micrometer. Means we have to keep these minds for the proper functioning of the optical fiber. Now, on which principle it works? So basically, optical fibers work on the principle of total internal reflection, critical angle. As you can see the picture, you can see the A, B, and C marked here. So first of all, we will explain that if we throw or if we incident a light signal from a phi 1, so we have the two different medium, that is N1 and N2, and the refractive. So also some constant that refractive index of N1 must be greater than N2. Here, N1 is the refractive index of the core and N2 is the refractive index of the clad. So we have to keep in mind that effective index of the core must be greater than cladding. So here in first, we can get, if we throw an incident phi 1 goes back in the same medium, but some part is also reflected, that is transmitted, as you can see. Again, if we throw the signals, but having the signal that is transmitted or refracted ray is 90 degree, forms a 90 degree, then its angle is said to be critical angle. And beyond that, if we throw our signal greater than critical angle, that is phi c, must phi 1 or our throwing signal must be greater than critical angle, then that ray reflect back in the same medium. Means the light ray reflect back in the core medium. It does not allow to fall in the clad. So this phenomena occurs, and this is the basic principle for total internal reflection. And at the bottom, you can see that sine from Snell's law, we can get sine phi sig must be equals to N2 upon N1. So basically, in optical fiber, total internal reflection occurs, which allows our signals must be in the same medium, that is in core medium. Now, according to our fiber fabrication, till now we have got the mind that which principle it works. Now, according to that, fiber fabrication is also there. So we have to need some material on which we can prepare. So for the metal purpose, we have to need only two things, or plastic or glass. So according to our need, we have to get either core as a plastic or a glass as a clad, or we can interchange according to our need, on which principle or which application we are using. So company has to get the mind that what type of clad or core should be, either plastic or the glass. So glass in glass, we can get that around germanium is mixed with silicon dioxide, and in plastics we have to get PMMA or some other polymer through which we can get a thin-like structure with a hole in the middle. And the method in which these fibers can be prepared, that is two different methods, that is MCVD, that is vapor phase oxidation process, and another one is direct melt method. In MCVD method, we can get the SU system where all the polymer is heated with some furnace system, and through which some tube-like structure is found in the other end. Where is the direct melt method? This glass core is in the molded form, and at the bottom we can draw the pipes according to our need, or pipes or fibers according to our need. So basically, we in companies, different fabrication companies, they are adopting these two techniques. Now, next one is classification of optical fiber. Means optical fiber further classified into two subcategories, or according to our need, or person's need, or company need, or country needs. We have to classify into two subcategories. That is number of modes and the refractive index. Modes means a number of reflection it occurs, means it requires any reflection or no reflection. So it divides into further two categories, that is single mode fiber and multi-mode fiber. The refract and according to refractive index means changement in the refractive index of the core and the clad. We can get strip index optical fiber and the graded index optical fiber. Now, first one is single mode fiber. As the name suggests, single mode. Single means one, in which no reflection occurs. So as you can see from the bottom picture, that one single light is transmitted without any reflection process. So in this, the best source for the transmitting the signals, that is laser light. That is, it carries light pulse around single path. Only the lowest order fundamental mode can propagate in the fiber, and all higher models are under cutoff condition, that is non-propagating. It uses basically laser light. So as you can see also from the picture, that is light is transmitted or received at the one single light. A single mode fiber, only one mode can propagate through the fiber. Its core diameter around 5 micrometer, and the clad thickness is around 70 micrometer. So we have to keep in mind for the single mode operation, we have to get this fabrication process. Now the difference between the refractive index of core and the cladding must be very small. There is neither dispersion nor deterioration, therefore it is suitable for long distance communication. Means it does not having less loss or dispersion from this type of fibers. The light is passed through the single mode fiber through laser diode. Means for transmitting of our signal, we have to use some type of lasers according to our need. Now, in multi-mode fiber means there is a multiple signals we can get or transmitted in a single fiber, or multi means many. So as you can see from the picture, that multi-mode fiber is going through from the fiber, that is one is this, one is upward down, and one is goes straight. So at one single fiber, it allows a large number of mode for light rays traveling through it. The core diameter is about 40 micrometer, and that of cladding is 70 micrometer. Means for the core diameter is around 40 micrometer, and the core cladding diameter should be 70 micrometer. Means with respect to single mode, we have to keep in mind the thickness of the core should be 40 micrometer. So there is a large difference. Obviously, there should be large difference between the refractive index of the single core and multi-mode. there is always a signal degradation due to multiple dispersion. Why? Because if we throw more than 2 or 3 light ray in a single fiber, there should be chances of degradation of these signals. So it is not suitable for long distance communication due to large dispersion attenuation. Means for if we are using multimode fiber, then we should keep in mind that we should throw for using a short distance, we have to use multi-mode fiber. For a long distance, we can use single mode fiber. So also we can further divide optical fiber on the basis of refractive index. So basically, they're further divided into 2 parts: step index optical fiber and the graded index optical fiber. So in step index optical fiber, there is a change in the fabrication process. As you can see, the thickness of the core should be around 200 micrometer, and the cladding thickness should be around 380 micrometer. Whereas in graded index fiber, the core diameter should be around 50 to 100 micrometer, and the thickness of the clad should be around 120 micrometer. So you can see from the above 2 pictures that it shows multiple reflection, but whereas in graded index fiber, it does not having a good reflection, only just touching or without touching the core and clad interface. As you can see from helical like structure, you can see, so there is a no reflection occurs in, but where in single step index fiber, there is a multiple reflection occurs between core and cladding interface. So basically, in single index fiber, the refractive index of the core and cladding are constant. We have to keep in mind that the refractive index core and the cladding must be constant. The light to propagate through in the form of meridianal way, which crosses the fiber axis through every direction of the core and cladding body. Means there should be a proper reflection process. Whereas in graded index fiber, there is a non-uniform refractive index of the core that gradually decreases from the center toward the core cladding interface. Means only the refractive index of the core changes from initially to middle end, and the cladding has a uniform refractive index. That has to be clear in the mind. The light rays propagate through in the form of helical rays, as we depicted in the picture. They never crosses the fiber axis. Now, if we compare these 2 things, multi-mode versus single mode, we can get that in multi-mode, it's usually used for the LAN, SAN, or some short distance applications. Whereas single mode, it is usually for WAN, MAN, or SIS, or in campus, or it connected from one city to another city. So basically, it can use for up to distance 2 kilometer, and whereas single mode, it more than 60 to 100 kilometer. Means we can connect one city to another city, so we can use this single mode of fire. Whereas multi-mode, it used for only for short distance. Although it require a very low less system, whereas single mode fiber, it required higher system cost. So without the cost, it can bear the lot of things. Now, as we transfer our signals from one end to another other end, there should be loss obviously there. So already we know that nothing is perfect. Some losses or some power loss or some degradation is always there in the system, either in physical things or in communication channel or in normal life. There nothing is perfect. So always there is an attenuation. Right? So attenuation is nothing, just a loss. It's just synonyms of the loss. So attenuation is the loss of optical fiber. It is the reduction of signal strength or light power over the length of the light carrying medium. So basically, it divided into three sub losses, mainly due to light absorbing, scattering, and bending loss. Light absorbing means light is absorbed at the some interface, core cladding interface. Scattered is also there, So scattering and bending loss is also there. So bending loss also you can see from the picture that due to some physical pressure or some other things, we can see that external force is applied. So there is no proper reflection occurs, and therefore our signal is lost or distorted. You can see from this figure that an original signal is there, attenuated, and again at the receiving end, amplified signal is also there. So we have to remove these things for getting proper signal transmission. Another one is also dispersion. I mean, for dispersion and attenuation, we can categorize this in the loss condition. So dispersion is also you can categorize in the loss signal. In dispersion means at the receiving end, there is a delay between the different rays, time interval. This is the time distortion of an optical signal that is result from the time of flight difference of different component of that signal result in the pulse broadening. Means at the single time, we are getting time delay of the light waves. Means at the receiving end, we're getting different time interval of signals, optical signals. This also causes the loss, or we cannot detect the signals in a proper way. So it also divided into two subcategories. Is consist of intramodal dispersion, and another one is intermodal dispersion. So in intermodal dispersion, it occurs due to material dispersion, means material due to defects in the core cladding interface, or the at the time of process, there is a defects due to which it occurs this type of dispersion. And wavelength dispersion is just at the receiving end, we are getting a delay in the process of the light, so get the wavelength dispersion. And intermodal dispersion means basically it occurs in multi-mode fibers, means if to it connected to the different modes or different multi-mode fibers, it occurs this intermodal dispersion. So if we give good communication channel, we have to remove these to do things, that is attenuation and the dispersion things. Now, moving towards these advantages of optical fibers, as we know that now today's world, we are using optical fiber due to its bandwidth. Means in the single fibers around a single thin like hair-like structure, we can transmit our signals in a broader way. And also electrical oscillations are very less. Very low transmission loss means the loss is very low, and also having a good thing that is having small size and lightweight. High signal security. For this security, we can use for the some security purpose, like in our defense purpose. Very low power consumption. This is very good thing that it requires only few watts for the proper function of this optical fiber, due to which its wide scope of system expansion. Also, if something has advantages, also it has some disadvantages. That is, system installation is very costly. So only point-to-point communication is possible through this technique. Precise and costly instrument would be required for the proper installation. The splicing time consuming is also there, and it's accept only unipolar codes. Means if we are converting the signals into some code, so required it's some hectic codes for the transmission of our signals. Now, why this advancement in the optical fibers, or if we compare with the normal wire or copper wire, the choice is also clear from this picture, that if we neglect the cost process, other things in favor with the optical fiber. That is, it can live up to 30 to 50 years. If install these things, it does not any things or corroded. Due to this, around it required only for 30 to 50 years. On a normal wire, it can last up to 5 or 6 or 8 years. And also distance covers a large distance. Weight is always low with respect to copper wire. Energy consumption is very requires only 2 watt or maybe less than, and for copper wire it more than 10 watts per user, and a maximum width is around 69 terabyte per second, and also it's 10 gigabyte per second. For security purpose, it's hard to clear this information in any way. It emits EMI, so it requires very lossless transmission in the copper, whereas in for optical fiber, it's very hard to detect. So we can get from this tab that optical fiber is much better than copper wire. Now, due to this, it's have a wide applications. One is on today's world, all the telecommunication purpose, all the telecommunication or mobiles, all these things are going through this optical fiber. In civil, customer, industrial application, they are adopting these optical fibers. And now today's world, all the operations or the sophisticated operation in our body is going through this fibrous structures. Due to this is said to be endoscopy technique. Now, for this security purpose, it is very useful in our military applications. Having bandwidth is also useful in broadband application, and also in our some household festivals or some things decoration purpose. We use these optical fiber, very cheap, also cheap optical fibers also available. So it has a lot of applications for using these optical fibers. So till now we have discussed that it gives a lot of good things with respect to copper wire. So at the end, if we neglect its cost, we can avoid. So it revolutionize the field of communication due to this advancement. So now today's world, you can see that our data plan, our internet data plan is declining day by day. Why? Due to this advancement of the optical fiber. Before that, we are using the internet in our mobile around MBs. Now today world, we are working on the GBs, or in further smart, we can also use in the terabyte per second. So I hope you can get some overview of the fundamentals of optical fiber, or where you can use optical fiber, or where it is used, or how it look like. I hope you can get all the things. Before I'm concluding all these things, at the end, I have written something that always over the solution of the problem means don't hesitate, have a solution, and go toward the solution of the problem. Thank you.